Hey, welcome back. I'm super excited to launch a new and improved Shader Park plugin for TouchDesigner. If you're new to Shader Park, it's a JavaScript library for creating interactive procedural 2D and 3D raymarched shaders. So something like this, or also the shader that you're seeing in the background of the website here. And the really nice thing is that Shader Park actually runs in the browser, so all the things you're seeing here will run on any device, but because of the TouchDesigner plugin, it also will run natively within TouchDesigner. So you can hook up sensors, make things audio reactive, or even ramp up the quality so that you can have a really nice final recording. If you're interested in getting started with Shader Park, I have a beginner tutorial series on YouTube that I'll put a link to in the description that'll help you get up and running. So let's go ahead and dive into the new features. So the first thing, there's actually no installation process anymore. All you need to do is go on over to the Shader Park GitHub page, which I'll put a link to in the description. And under the Shader Park TouchDesigner route, there's going to be a download link, which will download the actual TOX file. From there, what you can do is head on over to TouchDesigner and drag and drop the TOX file into your TouchDesigner project. And what's great is that you can take any of your Shader Park code. So let's say I took this sculpture that I've created. I can copy this code, go over to TouchDesigner, place down a text dat, and then now I can paste the code in and it will immediately render it. And the other thing too is that it'll live update, which is super nice. So I can go in here and I can change the code and it will update on the fly. So you can actually use it as a live programming interface. For the next two features, I actually want to give a huge shout out to Josef Pelz. He helped port these features into the new plugin. So previously, you could use either Shader Park's built-in lighting or you could use TouchDesigner's lighting. And in this new plugin, if you enable TouchDesigner's lighting, you can actually use shadows from the light sources within TouchDesigner. The other big feature is that the Shader Park objects will now interact correctly with other geometries that you're rendering within TouchDesigner. So for example, if I put another piece of geometry in, it will actually intersect and occlude with the other objects in the scene, which is great. And the other thing too is that you can now take the Shader Park geometry and you can very easily move it around or scale things up and down within the environment to just make it a lot easier to experiment with. So another bonus feature is that this new plugin actually supports T3D, which is a new operator family by Josef Pelz that allows you to work with 3D textures. And it's really nice because it allows you to do things like 3D reaction diffusion or 3D feedback loops. And you can actually use Shader Park as some of your starting geometry. So if you stick around to the end, I'll show you how to get everything hooked up. Before we jump into using the component, I also want to give a huge shout out to Peter Witten. So Peter and I actually co-created Shader Park together. And if you want to support Peter, I think a good way to doing that is to check out his YouTube channel. He's made this really incredible video on training an AI from scratch and how to play Pokemon using reinforcement learning. He's also got a number of projects on GitHub that you should check out, and I'll put a link to both of those in the description. All right, let's go ahead and dive into using the component. So high level, the first thing that you might want to do is just be able to really easily render some content using the plugin. So first thing, if you want to change the resolution, you can actually do so on the highest level of the component here, and then it will output on a transparent background, so you can just render this to a video. The second output here, this is actually to connect the source code to the T3D operator, which I'll get into later. But really the majority of this is actually inside the component. So here, this is just kind of a container for the render network, but if we go inside, the real Shader Park plugin is right here. And what this does is it'll take your JavaScript Shader Park code and it will convert it into a shader. And you can see here, it's actually being used in a PBR material. So this is a little PBR material that's then applied to a piece of geometry. One of the first things that I want to show you how to do is that on this Shader Park plugin right here, this will actually allow you to download new updates of the core library. So here, notice that there's this Shader Park version, and if you click on it, there's going to be a drop down of like the newer versions. And so if you click download library update, that will actually bring it in and you will be able to see if there are any updates for the Shader Park library. And then if you select it and click download, it will download the latest version, which is great. So that way you can just use the same component and then keep it up to date really easily within the component. So one thing that might not be apparent right away is that raymarching, when we're working with Shader Park, is actually an entirely different rendering technique than what we might be used to within TouchDesigner. So normally we kind of go about things by starting with a piece of geometry, and then maybe we apply a material like a PBR to it and then render that. So one thing that's super interesting about raymarching shaders is that we are actually simulating a 3D scene inside the material of this object. So if I take our sphere right here and I kind of scale it down, you'll notice suddenly it's kind of a bounding box in some ways for this separate 3D scene. And so what's kind of fun here, if you want, you can actually use this as an effect. So let's say we bring in a different piece of geometry, like maybe we go into the file in and we bring in the teapot. And in here, I'll insert a transform so that way I can scale the teapot size down. And check this out. Now, suddenly we've got our teapot, but it's taking on the shape of the object that we were working with. There it is. So we can kind of move it around and we can apply a custom shader to that object. That might be one approach that you might want to do, but I also like just rendering these as standalone scenes. So in that case, in general, you'll want to take your sphere, your kind of bounding geometry, and you'll scale that up much, much larger. And actually, if you go to the Shader Park website and you go to the code editor, you'll notice that we're doing something very similar here. So in the browser, if I take this starting sphere and I scale it up much larger to about a size of like 1.4, notice that the bounding geometry is actually a cube here in the browser. And so we're basically simulating an entire 3D scene inside the material of that cube. So what's the advantage of doing that? It actually gives us some really, really unique properties. And when we are raymarching, we're actually using a different type of geometry. So normally when let's say you want to make a sphere, you actually have to add in a bunch of small points in order to make a really detailed sphere. And we can see that over here. Like if you go into the detail panel and we change the number of rows and columns, notice that if we kind of reduce the quality of this sphere, we kind of get a very jagged sphere. And we have to increase the number of points that are used to create this sphere. One of the really interesting properties when we're working with, it's called a signed distance function. Those are the types of geometries that we're working with when we're raymarching, is that making a sphere is actually one of the simplest things to create. And really what we're doing here is representing a sphere as a function of space. So making a sphere, we actually get a really, really smooth surface by default. And the other thing is that it also gives us the ability to blend between different shapes super, super easily. So let's say I make a box. What I can do is mix between these two by the sign of time, by the end sign of time. And now we'll blend between these two shapes. You can also do things like take an object and we can mirror it many, many, many times, kind of like what you would do with instancing to create many iterations of that. But what's really interesting is that instead of duplicating the geometry, we're actually taking the space that the object sits in and we're duplicating the space. And you can also do things like constructive solid geometry. So here I could maybe make a torus. And I'll reset everything so that way it's not also getting mirrored many, many times, and I'll scale it up. And then now, if I intersect those two, we'll get only the area where the torus intersects with it. So let's try rotating it also. We can add time in, and then now suddenly we can get this really interesting animation. Okay, so that's just a couple of details to show you why raymarching and working with distance fields can be a really interesting approach. Oh, the other part too is that you can also get reflections super, super easily. So one thing that you might run into if you're bringing a shader from Shader Park into TouchDesigner is that you might need the ability to work with a uniform, which is a way to basically get inputs into your shader. So in Shader Park, those are called inputs. And the way we can work with them, let's say I make a variable called size, and I call input right here. Notice that it automatically made a slider for us, And if we use this size variable instead of our value, now I can use this slider to scale it up and down. So now what we can do, let's try to bring this into the TouchDesigner plugin. So here, if I paste this in, it will render, but notice that we might actually get an error. And the reason is because we haven't defined a uniform called size. So in general, if we're working with shaders, you need to actually go in, and we scroll to the very top, we can add in the vectors tab, we can hit the little plus mark right here, and we can define a uniform called size. And then what we can do is we can scale it right here. And now this is a really easy way to get input from TouchDesigner into our shader to control it. So for example, I could make an LFO and make it null, and then pass this LFO onto our size and then control it externally. So this is a really easy way to control things if you want to bring in audio reactivity or if you want to connect a sensor like a MIDI controller. The other thing that I want to note is that if you mistype any parts of the JavaScript or the shader park library, let's say we type in peer instead of sphere, you'll get an error here, but if you go inside this and go to the actual component here, notice that we'll get a actual more detailed error. So reference error, peer is not defined. So hopefully these errors will give you a little bit more information about what's going on, and you'll be able to get probably more detailed error messages if you take your code and you put it into the actual editor in Shader Park, but you notice that it's the same set of errors here. So reference error, peer is not defined, and hopefully that can give you a sense of how to fix your code. So the next thing I want to do is show you how to work with either Shader Park's lighting or TouchDesigner's built-in lighting. And the way we can do that is by going over to the shader material here and go to the vectors tab. And if you scroll down, you'll notice that there is this use TD lighting uniform. And so if we start to take this first parameter here and we start to increase it, well, actually at 0.5, we're using half of Shader Park's lighting and half of TouchDesigner's lighting. And once this is at 1, now we're fully using TouchDesigner's lighting. And you'll notice that we actually have these parameters up here, and these match a PBR material. So roughness, if we set it to 1, it's going to be more rough. If we set it to 0, it's not going to be rough at all and be much more reflective, especially when we have this metallic property increased. And so what we can do here is that it's actually picking up our lighting from this environment light here and then these two light sources here that also have soft shadows enabled. And what's really fun is that you can do anything you want with this lighting input. So you could even do something like bring in the webcam. And you could project it on it. So one thing that you might notice, if you normally try to update an environment light in real time, the frame rate will just drop entirely. And so a way to get around that is by going to the environment light, this use pre-filter maps, if you turn it off, it will allow you to update it in real time. And so now we can actually take on some of the lighting properties in here. And let's play around again with the roughness and see how that changes things. So at 0, it's fully mirrored surface, and with a little bit of roughness, it's kind of nice actually. So this could be an easy way of making it look like you have this sort of metallic object that is in your space. And maybe we composite it over our actual webcam. Look at that, cool. So the next thing I want to do is show you how to take Josef's T3D operators and then combine them with Shader Park. So for starters, go ahead and head on over to Josef's Patreon, which I'll put a link to in the description. And once you're signed up, you can actually download his T3D operators. Currently the version is 1.2, and maybe when you're watching this video, there could be a newer version, but there is a T3D Talks. And so you can download that and then drag and drop it into your TouchDesigner project. And once you have dragged and dropped it, notice that there is this T3D operator up here in the corner. So now when you hit tab on the keyboard, you'll actually get this custom set of operators. So the most minimal setup for T3D is to place down a shape, and notice that you get a couple different starting shapes. You have a sphere, box, and a torus. And from here, we can connect it to the surface operator. And this is basically a geometry. And notice we can see a little preview render here, and then we'll set up kind of our classic approach for a render network. So maybe we'll put down a renderer, and We'll set up a camera. We'll also make a environment light. And then we'll connect a constant top to a null, and then we'll connect the null, drag and drop it onto the environment map, and set it as the environment map parameter. And notice it's not going to pick up that lighting by default, and that's because we need to go to the material over here and switch it from a Phong to a PBR, and now we get that kind of soft glow. I'll connect this to an out and turn it on the background. And maybe we'll also add in a RGB key for black background. So the other part too is that you'll notice that when you first start making some of these shapes that they can look a little jagged around the edges. And one way to fix that is by bumping up the resolution here. So it's all 64 by 64. Let's try 128 by 128 by 128. The one thing I want to show you now is how to use Shader Park in order to create a starting shape instead of using something like a sphere or a box or a torus. We can actually make some really interesting starting shapes. So the way we can do that is by going into T3D, and notice that there's this SDF operator. If we place this down and we connect this instead, it's not gonna really show up with something that we want by default. And the reason is if you go to the output, you need to change it from distance to inside. And this one, if we go in, and usually what you need to do is change this threshold to figure out like where you're intersecting the object. So this is a little, a gyroid actually that is defined here in this little text file. So you'll notice distance fields, SDFs, are just a function of space. And so we can actually modify this code right here. This is something that I made a while back, and we can delete the content of this SDF function, and all we need to do is return a function that tells us whether or not we're inside or outside of the shape. And notice that there's a little helper function for sphere right here. If we return sphere of P, which is our position that we're going to be sampling from, and give it a size like 0.2 and put a semicolon there, notice, hey, we get our little starting sphere. Well, one of the really nice things is that Shader Park right here will actually output, if we place a null text stat, it's actually going to output a SDF function for us. And so here, instead of using this little text file, we can actually just drag and drop on this T3D SDF operator. Notice that there's a placeholder here. It's looking for a file called SDF, which is the name of it here. We can take this little text stat, drag and drop it onto the SDF piece right here, and now we'll start rendering that shape. So we actually don't even need this little SDF operator or this little text stat containing our distance function. And what's great is that we can now start customizing it. So from here, maybe I'll bump up the lighting a little bit more so it's a little bit brighter, and then we'll bring the camera in a little bit closer. And right, so it's a little jagged right now, and maybe a simple way of fixing that is by going to the common section here and again bumping up the resolution. If you really want to ramp it up, for example, when you're recording a video, you can bump it up very, very high and kind of see what your computer will handle, and that will get rid of these little artifacts kind of around the edges. And another simple way of cleaning up those edges is also by inserting a anti-alias right here after the renderer, and we can bump that up to ultra. Okay, that'll get rid of some of the little finer details there. So one thing we might want to do is actually animate this shape. So let's say, for example, over here, if I go back in and add time in, well, this is a predefined uniform within Shader Park, but it's not actually going to be available in T3D. So from here, if I copy this code and I paste it in and render that, notice that our shape is now animating in Shader Park, but it's not animating in T3D. So if we go inside this T3D SDF, you'll actually see right here that on the GLSL component that we have a little warning, and it says, hey, the uniform time isn't assigned. So let's go ahead and make it. If we add in the time operator or the time uniform, and then now if we add in me.time.frame times 0.01, and we zoom out, notice that we'll start getting that piece animating. This can be a really, really easy space as well to add in something like audio reactivity. So if you were to drop in some audio analysis, a really nice way of being able to animate your object with audio reactivity is to apply your audio analysis here with a value that'll continuously count up. I think that kind of wraps up in general the process of bringing things from Shader Park into T3D. Josef goes over some really great examples about how to use 3D reaction diffusion or feedback loops in general with T3D, and this can be a great way of kind of combining those together. So I would definitely recommend checking out those tutorials as well, which I'll put a link to in the description. Cool, I hope this is helpful, and I'm really excited to see what you all will make. And if you enjoyed this type of content, consider giving the video a like or subscribing to the channel. I also have a Patreon where I publish different plugins and different tutorials and project files as well, and I'll put a link to that in the description. Thanks again, look forward to seeing you in the next one.